Okay. Okay, now I have to figure out what I was doing before. Okay. Yeah, I think I got it now. We create two arrays and then move and then copy it from the source to the destination array. Okay. Now we're going to do the same thing, but instead we're going to copy it into a neural network. But first you have to figure out where are we in neural network. We had add layer and then add null layers. Okay, so far we only have null layers, but we're going to add different kinds of layers afterwards. Okay, neural network, type neural network, create. Wait a minute, type neural network, create. Type neural network, create. How do we create it? And network. Okay, and network. What else do I need? I need to make sure you get this right. We just create a network. Okay, add layer null. Not feed. Oh, I got the name wrong. Oh, I got the name so completely wrong. That's a mistake. Feed forward array, add layer null, feed forward, backpropagate array, get outputs, and then get feed forward and backpropagate. Okay, add layer null. Ah, that's completely wrong. Okay, add layer null width, height, and depth. Add layer null network and network. Okay, now we need to add a layer. Width is same as this. Okay, we're just gonna keep it the same. Okay, and one thing to remember is that the network needs at least 2 layers. The final layer doesn't do anything. It should be a null layer, but we need at least 2. Just copy it. Let's say 4 layers. Okay, now let's change this right here. Set image RGB source, and then we have to feed forward. Network feed forward array. We don't have backpropagate yet, but we will afterwards. Feed forward array and network. Doesn't really look good because it doesn't actually do anything. Feed forward array source. Now we feed forward. Now we have to do something else. And source. Now we have to get the outputs into, because even if we feed forward, we can actually get the image. Get image RGB only works on arrays, not on networks. So that's why we have arrays, layers, and then networks. 3 separate structures. Seems a bit complicated, but in order to have maximum flexibility, we have to have all 3. It is possible to do it all in one, but it will just complicate things. Okay, result. This probably won't work, but just have to test it and make sure if we made a mistake, and if we did, we'll correct it. Okay, build, save everything. Oh no, it doesn't save. Okay, build. Okay, build solution. It's building. Nope. I made a few mistakes here. Okay, I'm gonna have to correct those. Oh, then I didn't make an error at all. I just forgot to save the neural network part. I had made the previous error calling it feed add layer null, but for some reason it didn't save. So it looks like everything could be working right. Let's see. Is it saving? Yes. Not sure if it's actually working, but it looks like it's working. Let's just test it to make sure that it actually works. Okay, feed forward. Let's go debug. First, we have to walk to the code, see if everything is happening the way it's supposed to. Okay, Control F9. Okay. It's not doing anything. Oh, there it is. Okay. F10. Feed forward. Set the layer. Let layer array, get the layer array from the parent.network data array data. I should change this. This is a very bad function. I really don't like this one. I'm gonna change this later. Neural array copy. Just copy for each item. Copy from one layer to the next. And so far it's working. Continue, and it works. But that's too simple. Now we have to do something slightly different. Okay, neural network. We have to create a new type of layer. What other type of layer? Now that's the old type of layer. And now we have to create a new type of layer called, we have several options here. Should we, a null layer, a bias layer? Yeah, a bias layer. Oh wait, a random layer maybe. Okay, let's create a bias layer. It will show us exactly what's going on. Okay, create a new file. New file. Header file. Okay, if and def, what should we call it? I don't know what to call it. Type neural layer bias. Copy everything here. Am I in the right place? Yeah. Type neural layer bias. Type neural layer bias. Okay, and if. And the if. Okay, include type neural layer .h. Oh, wait, what am I doing? Okay, there's just too many files here. Let me clean this up. Okay, close this, close this. Oh, close this and this and this and not this. That's too much stuff. Okay, where am I? Type layer. It's not clear what I'm doing here. Include that neural layer log. Let's add this one here. That neural layer bias. A bias layer simply adds a certain value to the value that it's fed into. Okay, but what does it do? Okay, we just have to copy everything that we did here. Feed forward. How does bias layer feed forward? Okay, bias layer create. Oh wait, type neural layer create. Type neural layer bias. Type neural layer bias create. Everything is the same. A bias layer needs to have the next layer be the same size. If okay, what if create if we create the bias layer this exactly same way we create with the exact same function that we create a basic layer. If we can create a basic layer, then we can add to it. If that neural layer create parent width, height, and depth. Okay, why is it not responding? I don't know. Okay, width, height, and depth. That means it works. Why is it not responding? Okay, if we create it right, are we missing something here? It seems like we're missing something. Neural layer. I don't know. Oh, there's an error somewhere. Well, if there is, I can't find it. Okay, if that neural layer create, we add extra layers. If okay, neural create outputs, not weights. Vectors. Okay, width, height, and depth. Actually, you don't need if, because if it doesn't work, then the whole thing will just not work at all. So no need to do a check. I think it's safe. We create the weight and vectors and we return 1. I still don't understand why it's not clearing it. Maybe I made a mistake somewhere. Okay, feed forward. bias feed forward is slightly different from the other type feed forward. That neural layer feed forward, neural layer bias feed forward. Okay, how do we feed forward in a bias layer? Everything's the same. Yeah, everything's the same. That neural layer multiply. Okay, we multiply. We store next layer outputs, parent.layer output times parent.layer weights. It's very simple. We just multiplied the outputs by the weights and then store in the next layer. Well, no. Actually, that's completely wrong. That is completely wrong. It's add, not multiply. It's add, not multiply. We add the outputs to the weights. It's add, not multiply. I'm not thinking very. I'm not thinking very well here. Okay, we multiply, and now we backpropagate. Neural layer bias backpropagate. All the layers use the same values. Did I include the bias here? Alright, weights are here. Yeah, it works. Everything works. Okay. But how do you do backpropagation in bias? Actually, you don't add anything. You just copy. Yeah, everything's the same. When feeding forward in a bias, you add the bias, but when backpropagating, you don't add anything. You just copy the derivatives, but you still update the weights. Okay, but now we need a third function, update weights. Null layer bias update weights. Null layers do not need updating, but update weights. Oh, I can't spell at all. Update weights parent. Do we need next? Update weight needs next, I think. I think it does. Okay, updating your weights is relatively simple, but well, actually, it gets really complicated. It starts out simple and it gets really complicated very quickly. We can do it in a very basic way, but not sure if we should. Let's just do it. Add. How do we update the weights? This is going to get complicated very quickly. Yeah, skip that for now because updating the weights requires a special update function with momentum, and let's just do nothing. Return 1. Let's just do nothing for now because that gets really complicated very quickly. And destroy. Normally I'd just do the same thing, but we have to add special things, add extra details. Okay, each layer type is going to use different kinds of arrays, different kinds of structure inside the layer. So destroy if parent.destroy. Now if that neural layer destroy. Not that neural layer destroy. No, we don't need 0. If that neural layer destroy with parent, we destroy weights and vectors. Weights and vectors. Okay, for now, we'll just make sure that it works. Oh, wait, that doesn't work. That does not work at all. Because that's just stupid. That doesn't work. It just doesn't work. If parent equals 0, return 0. This cannot work because if you call neural layer destroy, then everything gets set to 0 before you can destroy the array. So now you have a 0 pointer and a memory leak. That just doesn't work at all. That's just stupid. Okay, so you do it in reverse. And Actually, we just call return. We just destroy the arrays that you use yourself here, and you call layer destroy at the end. That's the safest way to do it. Okay, but here's something else that I forget. You have to set the array to some random value. This is one of those things that really becomes a problem. You have to fill a certain value in the array. So now we go into null arrays. Wait a minute. Turn out the error that I was getting is I forgot to save the file. That's it. Okay, we can't simply create the array. We have to fill it to a specific with some kind of value. So on top of add and subtract and all the other stuff, you have to fill it with different values. Okay, null array copy. Copy. Null array fill. Fill 0. Fill 0. Oh, there's no source. Fill 0 parent. No, we don't need that. This is promising to be very difficult. Fill 0 parent if no, there is no source to array length. For I equal parent.array length, parent.array data equals 0. Very simple function. Fill 1. I'm copying from the NumPy functions. NumPy has a function, so NumPy and TensorFlow functions are zeros and ones. Fill 1. Set our value to 1, 0 and 1. Okay, now for fill random. This is more complicated. Fill random. There are different kinds of random, like random uniform, random other stuff, but for now I'm going to set a simple kind of random. Okay, so you're just going to use the basic random with time and everything. The same random we use up here. Okay, why do I need all this? Oh, this is just srand. Where do I use this? Srand right here. Srand times 0. Fill random, and then we see the random, and then am I in the right place? Yeah. Rand and rand max. I keep forgetting how I did that. Okay. Now I'm inside. I'm searching how to do random properly using rand max 1 in Stack Overflow. Rand max divide. Oh, there it is. Rand divided by rand max minus 1 plus 1. Okay. Okay. The rand divided by rand max. Random. Okay. Rand divided by rand max plus 1. Is that a floating point value? I'm still not sure how that works exactly. I have to figure this out. Okay, let's add it in a special function here. Static random double. No, not double here. Double. Static double random. Okay. 1 minus return random value divided by rand max. A double no, return rand, no, return, what am I doing? Return double divided by rand max plus 1. Is it minus 1 or plus 1? No, just divide by rand max. Why do I need plus 1 for? Not sure what is necessary. Okay, rand divided by, no need for parentheses here. Rand divided by rand max. Double rand divided by rand max should give us a value between 0 and 1. Okay, random. Return 1 minus random plus random. The point of this is that it gives us a value that's between 1 and -1. When minus 1 plus random. Okay, fill random. Okay, where am I? Yeah. Type sequence, type neural array. We are to random. If it doesn't work, we'll fix it. But there I was. Okay, type neural array. Type neural array. Fill random. Fill random. There are other functions to use, but so far this one should do. Fill random. Parents dot layer weights. We're not going to use vectors, so it doesn't matter. Okay, fill 0. Parents dot layer vectors. What? Oh, why does it do that? Fill random dot layer vectors. Okay, what did you forget here? Oh, there it is. Bias. Yeah. I have to set the type. Yeah. Okay. Type no layer by layer type bias. Copy it up here. We have to set the layer type. Okay. Type no type bias. Okay. For the neural network, we added the layer create function, create layer bias create, and then everything else is the same. Layer null. Just copy everything and change null to bias. Bias feed forward. Bias feed forward. Case backpropagate. Bias backpropagate. The bias backpropagate, and then destroy. Bias destroy. Okay, that should be everything. Okay, what was I here? Okay, that should be everything. Build, no, save. Build, we build. Let's just make sure it works before we jump into and do anything. Forgot something again. I copied everything, but I forgot to include the I. Okay. Random I, add I. Everything should work. Build, we build. Okay, everything so far seems to work. Now we add the bias layer. Add layer bias. Bias. Now let's rebuild it again and see what we get. Probably we'll get something weird. Oh, wait, it works. Bias. There it goes. The bias is just a random value, random set of values, and it adds it to the image. Now we have bias. Let's add even more bias. Just see what happens. Okay. Just two should do. Let's see what happens. And surprisingly enough, it works. Now we added even more bias, and it worked right, which is again very surprising. Everything did not fail. We just have a lot of noise. Here. Okay, so it works. Okay, what else we're going to do? Oh, we have to update the weights. I don't know if I have time for this, but there's one extra function I want to include here. Okay, here's one very important function you're going to need when doing neural network stuff. Momentum. It's not the most complicated one, but it's kind of important. Why do I need all this? I don't need all this. Okay, momentum. Update momentum. neural array update momentum. Okay, what do I need? We need a neural array called weights, vectors, and what else we need? Deltas, derivatives. Deltas is I said derivatives. Deltas, not derivatives, just deltas. And also null unit, learning rate, learning rate, and what else? And learning rate and momentum. No, and the momentum value. CUDA null unit, type null unit, momentum. Jumping ahead of myself here. Momentum. Okay. Okay, how does it work? Everything's the same here. Not without weights. Vectors. No, vectors. Deltas. If weight dot array dot weights, vectors, and deltas. I think we should do this tomorrow, but I just want to get to it tonight. What do we do? What do we need? Okay. For each item in the weights. No, weights. For each item in the weights, vectors. No, vectors dot I equals. Let me show the equation. Okay, there's the equation I'm using here. Vectors equals learning momentum times 1 minus momentum. That's a weird version of it. But it gets the point across close enough. It's the momentum times the previous momentum. Momentum times previous momentum. The v equals momentum. Momentum at time step t times is momentum times step t plus 1 plus 1 minus momentum times the learning rate times the what's that called again? Times the delta at time steps t. Okay, that's what I'm using here. It's written in a very different way than I'm using. There it is. New weights. Momentum equals the new weight update. That's the vector. I call it vector, but here they call it something else. With the symbols that is the gradient, the delta. 1 minus delta, delta plus 1 minus delta plus something, plus the previous momentum. Let's just code it. We'll explain it later. Okay, momentum equals vector, vectors dot I times momentum plus, let's see if I get it right. Yeah, plus 1 minus momentum. It's been a while. Since 1 minus momentum. That's just a more accurate version of it. Okay, times the deltas. Okay, deltas dot I. Okay, here's something I'm not sure about, but that's just how I do it. You have to multiply the learning weight by something. Learning weight, but I just do it up here. Learning weight times deltas. I just do it up here, but you can do it down here instead. Okay, that's the first part. The second part is weights dot I equals weights dot I. now dot I plus vectors. Now what am I doing? Vectors dot I. Now it's the choice you have to make. I'm never quite sure which one works better. Is it learning rate times deltas here, or learning rate times vectors down here? Let's just do it up here. That just simplifies everything. Learning rate times deltas. That makes everything better. It makes everything look better. Okay, now what? Okay, what's the next thing? Next thing is update weights. Update momentum. We don't need that, JK. Whoa. Momentum's at I. Oh, we need I. No, unsigned. No. Unsigned long I. We need I. Okay, that's it. That's the basic momentum. Tap new all the way, update momentum. Now for bias. Bias update weights. Okay, update weights momentum. This one's rather parents.layer weights. Let's do it here. We need the 3 arrays. Parents.layer weights. Layer weights. Parents.layer vectors. Parent.layer deltas. Is it parents.layer deltas? No, it should be next.layer deltas. Actually, it doesn't make a difference because you just copy it, because so they're going to be the same. There should be next.layer deltas, but I'm not gonna care too much. Now for neural network, we have to add update weights to the list of functions. Update weights. Copy. Update weights. Parent.update weights. No, not backpropagate. Oh. Update weights. Okay. Null weights don't need to be updated. So bias. Oh, something else I can forget. It's the for. It's that for loop. It has to be done correctly. Okay, for loop. Parent.narrow bias update weights. Update weights. We keep everything the same just to be clear. Is it bias.update weights, or does it work? It should work. Backpropagate. Okay, let's assume everything works. Save everything here, and now let's try running it. We're already inside a loop, aren't we? Okay, yeah, we're already inside a loop. Okay, feed forward array, backpropagate array, backpropagate array, backpropagate array. No, not source. Yeah, backpropagate array. It's basically an autoencoder, so it's just backpropagate array, and then update weights. Copy. Update weights. Network. Oh, learning rate. Update weight. We're just gonna use a standard learning rate. Update weights is learning weight. Is what are the standard values? Learning weight. Bias update weights. Oh, we forgot something important again. Learning rate momentum. No array. Okay. Learning rate momentum. Yeah, don't be so difficult. Bias update weights. Learning rate momentum. Come on. Tapping on the learning rate momentum. Neural network. Update weights. No, it uses internally stuff. Okay, learning rate is 0.01. Momentum is 0.9. Those are just standard values. Just good values to use. Okay, save everything. Just make sure that it all works. Build. I probably have made several mistakes, but let's just see if I get everything right. Stop. A few typos. Vectors, not veltors. Binary plus plus operator. Sign unsigned mismatch. For loop. Unsigned long. No. Unsigned long. It's just being difficult again. Unsigned long I. And then save and we build. Type null rate. Save. Why do I have to save everything manually? Rebuild. Oh, shoot, it doesn't work again. And now I realize I made a lot of small errors. I don't have time for this. We'll start this up again tomorrow because this is completely wrong. It's supposed to be array data. Weights.array data. It's gonna take us so long to fix this. Let me just stop it and fix it there. Okay, I fixed the main error and then found out I made another stupid error. Something I didn't notice. If weights.array not equals, I just copied everything but didn't actually check if it was right. Okay, we just have to check that all the weights, all the arrays are the same size, and now we did. Build, rebuild. Yes. Build, rebuild. Now we have a problem again. And once again, we forget. That's just bad when you're trying to do all this just from memory. Okay, now we save it again and rebuild again. Okay, now let's see if it works. It should work. And it doesn't. Oh, it's working. It's working. You can see it here. It's working. It's clearing up. Yeah, that's right. Our neural network works perfectly. Finally. See, the bias is adapting, so the weight bias is adapting. The neural network is learning until it clears up the image. It was all worth it. Okay, let's try it again. Let's try it again, but this time we just add more bias. The problem is that this is very, 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 very slow because we're doing it with the CPU instead of the GPU, so it's going to get really, really, everything's just going to be very, very, very slow. Okay, just try it again, see if it works. Okay, it's working, but really, really slowly. Yeah, but you can see it right here. Yeah, you can see it. It's just adapting. The different layers are learning from each other, and until everything clears up. Let's try it again one more time. It's just so beautiful to see something actually work. Yeah, all noise, and then the noise is clearing up. We start from random values and it learns to reproduce the image. Simple autoencoder, but it's good enough. Okay, next time we're going to do something slightly different.